Ctené dámy, vážení páni, milí hostia, dovoľte, aby som vás privítal na podujatí Slovenského zväzu výrobcov tepla a Európskej federácie inteligentných služieb a energetickej efektívnosti. Som veľmi rád, že sa nám podarilo pripraviť takéto odborné podujatie na výmenu skúseností v rámci ďalkového vykurovania v rámci členov EFIEES a členov SZVT a samozrejme aj na určitú propagáciu ďalkového vykurovania ako vykurovania efektívneho a bezpečného a cenovo dostupného. Je nás tu dosť, čo som veľmi rád. A na úvod začnem možno netradične, ale ten, kto odborne pripravoval túto konferenciu a dal dokopy celý tento itinerár, dali dokopy speakerov, tak ja tie dve dámy teraz predstavím, mnohých poznáte. Jednak je to Valéria Pleymason, generálna sekretárka EFIEES. A moja pravá ruka v Slovenskom zväze výrobcov tepla, pani Martina Oleníková. Takže ak budú chvály na toto podujatie, tak som to ja, a keď nejaké nedostatky, nech sa páči. Úvodom predstavím našich dnešných hostí a dám im úvodom aj slovo. Som veľmi rád, že naše podujatie navštívil a povie aj pár vied k systémom štátny tajomník Ministerstva hospodárstva, pán Hodoši. A ďakujeme aj Stavebnej fakulte Slovenskej technickej univerzite za kooperáciu a spoluprácu a dnes v mene dekana nás poctila návštevou pani profesorka Gajdošová. Skôr ako veľmi stručne predstavím speakerov, veľmi máličko, poprosil by som ťa, pán štátny tajomník, o pár slov. My komunikujeme ako zväz veľmi intenzívne s Ministerstvom hospodárstva a s novým štátnym tajomníkom myslím, že sme nadviazali veľmi dobrú spoluprácu, vytvorenie takej platformy a začíname sa pozerať na energetiku a teplárenstvo globálne alebo komplexne. A sme veľmi radi, že máme možnosť komunikovať na jeho úrovni, vymeniať si skúsenosti a viac menej trošku aj začať ako manažovať bezpečnosť energetiky na Slovensku. Pán štátny tajomník, nech sa páči.
Ďakujem pekne. Ďakujem pekne za milé uvítanie a vlastne vyslovenie záväzku v podstate aj na tú ďalšiu spoluprácu. Veľmi sa teším, že tu môžem byť a trošku sa vnoriť do inotájov a tém sektora tepelnej energetiky, teplárenstva na Slovensku. Vážené dámy, vážení páni, dovoľte mi, aby som vás v mene Ministerstva hospodárstva srdečne pozdravil a poďakoval za možnosť vystúpiť na tomto podujatí, ktoré sa venuje jednej z najaktuálnejších tém energetickej transformácie, a to inteligentnému teplárenstvu. Z pohľadu budúcnosti vykurovania je potrebné sa zamerať na moderné technológie, ktoré premieňajú naše mesta na zelenšie Slovensko. Centrálne zásobovanie teplom na Slovensku totiž zabezpečuje dodávku tepla, iste vám známe, približne 20% obyvateľstva. Tým pádom je to možné považovať za kľúčový sektor národného hospodárstva. Sektor teplárenstva je tiež jednou z hlavných oblastí pri transformácii na nízkouhlíkovú ekonomiku, splnenie rôznych cieľov, ktoré sú nám kladené a predpisované aj zo strany Európskej komisie. Čo sa týka tých rámcov a cieľov, my sme spravili kus dobrej práce, vnímam aj v spolupráci práve so sektorom teplárenstva, samozrejme a s inými, pri aktualizácii integrovaného národného energetického klimatického plánu. Bol to náročný proces, chvíľku to trval, bolo tam, iste viete, veľa tém, Niektorí doprava, niektorí doľava. To nie je nikdy jednoduché nájsť nejaký rozumný kompromis, ale nakoniec sa podarilo završiť tento proces a vláda 2.4. tohto roka schválila tento materiál a my sme to notifikovali už smerom na komisiu. Čo sa týka významu sektoru teplárenstva, vidíme, že koľko legislatívnych aktov aj v oblasti EÚ sa na nás valí, chrlí a stále generujú sa ďalšie a ďalšie. Ja som bol v nemom úžase, priznám sa, keď po nástupe na ministerstvo ma kolegovci privítali, aké všetky legislatívne aktivity nás čakajú v najbližšie obdobie. Raz novelizovať zákony, energetika, tepelná energetika, 309, že toto poznáte z titulu ako reformy dizajnu trhu s elektrinou. Potom budeme robiť veľkú novelizáciu kvôli RED 3, kvôli smernici o energetickej efektívnosti a potom budeme robiť ešte aj gas package. A to všetko máme zvládnuť plus minus do 1 roka. Tak som sa veľmi potešil, že máme takéto ambiciózne plány a skvelý kolektív to zvládnuť, tak na strane ministerstva, ako aj na strane partnerov. Z pohľadu inteligentného teplárenstva je potrebné upriamiť našu pozornosť aj na nové požiadavky práve tej smernice o energetickej efektívnosti, ktoré vo významnej miere ovplyvňujú sektor vykurovania a chladenia. Smernica stanovuje požiadavky na plánovanie budúcnosti, zásobovania teplom a chladom, jasne definuje výzvy, ktoré je potrebné naplniť. Zároveň táto smernica stanovuje aj pravidlá pre účinné systémy CZT, požiadavky na znižovanie spotreby energie, ako aj verejný sektor, tak aj pre obnovu verejných budov. Je tam rad cieľov, reformy, však tá samotná smernica má cez 100 strán, je tam množstvo príloh, takže nie je to jednoduché uchopiť, ale zase vidíme tam potenciál, kam sa môžeme posunúť ako štát. Významné znižovanie potreby tepla vidíme, že môže prispieť potom aj k menšiemu využívaniu súčasných systémov výroby a dodávky tepla a tým pádom prichádza na rad otázka optimalizácie, ako tú optimalizáciu uchopiť. Ešte možno také info, čo je tiež vám zrejme známe, že čo sa týka zdrojov vysokoučinnej kombinovanej výroby, KVET je poskytovaná aj podpora práve z modernizačného fondu, kde je načrtnutá a poskytovaná investičná pomoc pre modernizáciu zdrojov, rozvodov a preto som rád, že na tomto mieste môžem povedať, že máme už za sebou nejaké rozhodovanie a v najbližšom období zrejme subjekty budú oslovené, ktorým sa pridelila dotácia z modernizačného fondu tohto roka. Hovoríme o nejakých 37 projektoch za 149 miliónov eur, ktoré dostanú podporu na konkrétne projekty. Zároveň by som rád dal do pozornosti aj špecifickú úlohu zdrojov VUQVET pri stabilizácii sektora energetiky, takže preto posudzujeme aj možnosti pokračovania prevádzkovej podpory a aj v súvislosti s energetickou náročnosťou. Jedným z mnohých kľúčových prvkov v rámci Slovenska je naplniť cieľy smernice, zvyšovať energetické využívanie odpadu. Prichádzajú pomaličky na rad témy aj odpadové teplo, ako s tým pracovať, ako aj začleniť teplo vyrobené z OZ, integráciu obnoviteľných zdrojov. Sú tu také novinky, témy, ktoré musia byť legislatívne uchopené, vytvorený dostatočný rámec, aby bol predikovateľný, aby jednotlivé tie subjekty, ktoré fungujú v teplárenstve, vedeli, do čoho investovať a vlastne ako nasmerovať aj modernizáciu, aj úpravu, aké ciele dosiahnuť a koľko to na konci dňa bude stáť. Samozrejme, vnímame, že takáto integrácia a riešenie týchto nových víziev musí sa odzrkadliť aj v regulačnom rámci pre dodávku tepla. Máme aj pozitívne novinky, príklady, čo sa týka aj geotermu. Už sa pozeráme aj týmto smerom a práve MHTH v Košiciach robí taký veľmi pekný projekt. Vnímam, že najväčšou ochranou pre budúcnosť centrálneho zásobovania teplom je aj otázka konkurencie schopnosti pri dodávke nízkouhlíkového tepla pre koncových odberateľov, v dôsledku čoho dávam do pozornosti aj pripravovanú novelu zákona o tepelnej energetike, ktorá má zlepšiť právnu istotu a umožniť investície do modernizácie s dôrazom na obnoviteľné zdroje a akumulácie energie. Máme nejaké špecifikum na Slovensku za ostatné obdobie a to je tá mimoriadna situácia na trhu, ktorá bola, čo sa týka cien palív. Dotklo sa nie len elektriky, plynu, ale samozrejme aj sektora teplárenstva a my fungujeme od roku 2023 na nejakých mimoriadnych opatreniach a vnímame, že aj sektor teplárenstva je mimoriadne citlivý. Z cieľom ochrany koncových odberateľov vláda siahla po krízovej regulácii a zastropovala nárast ceny tepla, aby bola nejaká garancia pre všetkých odberateľov, čo boli plošné dotácie, ktoré teraz pracujeme na tom, aby od budúceho roka boli adresné. A z tohto miesta by som veľmi významne ocenil príspevok zástupcov sektora teplárenstva. Či to boli SZVT alebo zväz, s ktorými sme riešili aj rozpočítavania tepla. Bolo rad úkonov, aktivít potrebných si vysvetliť, vďaka čomu sa podarilo nemať chaos pri fakturáciách tepla, ale mať doručenú tú pomoc tým odberateľom. Ako nakoniec môžem iba zhrnúť, že sektor teplárenstva stojí pred zásadnými výzvami spojenými s transformáciou na využívanie nízkouhlíkových zdrojov. Sme tu pred výzvami pri transpozícii, pri modernizácii, pri riešení otázok prevádzkovej podpory, pričom som však presvedčený, že sa nám podarí spoločnými silami tieto výzvy úspešne zvládnuť a zabezpečiť cenovo dostupné, environmentálne udržateľné teplo pre odberateľov na Slovensku. Preto verím a držíme palce aj zo strany Ministerstva hospodárstva, výskumu, technologickým inováciám, podnikateľskej odvahe a my zas budeme musieť si robiť našu úlohu v oblasti regulácie legislatívy. Máme tu nezávislého regulátora aj na ceny tepla a vnímam, že všetky tieto témy, o ktorých bude aj dnešná konferencia, sú mimoriadne významné, preto to podporujeme a prajem účastníkom tohto podujatia dobrú diskusiu, zaujímavé prezentácie a veľa úspechov pri naplňaní týchto aspektov. Ďakujem veľmi pekne.
A keďže sme na pôde stavebnej fakulty, teda na akademickej pôde, poprosili som pani prodekanku o pár úprimných slov.
Ďakujem veľmi pekne. Dobrý deň. Dovolte mi privítať vás na pôde Stavebnej fakulty Slovenskej technickej univerzity v Bratislave. Vidím tu celý čas pred sebou inteligentné teplo. Som rada, že ste práve tu, pretože ak tá inteligencia, ak tu niekde hľadáme, ak hľadáme technologický pokrok, inovácie, ktoré chceme zaviesť do praxe, tak myslím, že ste na správnom mieste. Práve toto by mala Technická univerzita zabezpečiť. Vítam pána štátneho tajomníka, vítam zástupcov Slovenského zväzu výrobcov tepla. And also I would like to welcome our special guests and the speakers. I hope you will enjoy this event and also Bratislava. Welcome at the Faculty of Civil Engineering of the Slovak University of Technology here in Bratislava. Želám vám všetkým, aby ste využili toto podujatie. Vidím tu veľa študentov, verím, že práve oni budú tí, ktorí sa dozvedia množstvo nových informácií, ktoré sa im stanú motiváciou, aby vedeli, akým smerom sa ďalej pozerať, čo je potrebné a s kým všetkým treba spolupracovať, aby sme sa posúvali v tom technologickom pokroku čo najďalej a čo najrýchlejšie. Takže želám vám príjemné podujatie a ešte raz vítajte u nás na Stavebnej fakulte.
Pomaličky sa posúvame ďalej. Ja by som toto úvodné kolečko si dovolil zakončiť tým, že by som privítal speakerov, ktorí dnes budú v podstate mať na starosti tú odbornú časť. Vítam pána Pascala Guillauma. Je to prezident Európskej federácie inteligentných služieb. A jeho pravú ruku v riadení celého združenia, generálnu tajomníčku pani Valérie Pleymanson. Vybrali sme speakerov tak, aby sme pokryli aj budovy, pokryli aj diaľkové vykurovanie a pokryli komplexne celú túto problematiku. Ďalším speakerom bude pán Tomáš Surma. A Francisco Marquez. teraz by malo byť, a skúsme si prehrať videjko. Je krátke, ale poučné.
La géothermie, je crois que c'est le chauffage avec des sources naturelles, je sais pas.
Pas du tout.
Non, pas du tout.
Ouais, pareil, je sais pas. Est-ce que c'est quelque chose pour le chauffage?
Je sais qu'il existe un chauffage, on va dire, collectif.
Ouais, c'est un concept de combustion, non je sais pas trop. C'est quoi la géothermie?
C'est quelque chose qu'on va chercher sous terre.
Aller chercher la chaleur, c'est un peu ce qui existe. Qui c'est qui pratique déjà la géothermie ici?
Alors la géothermie pour moi c'est l'utilisation des chaleurs à l'intérieur de la Terre pour justement chauffer éventuellement les habitations ou utiliser de l'énergie provenant de l'intérieur de la Terre.
Plus on descendra bas, plus ça sera chaud d'ailleurs, parce que si on arrive au magma central, ça pourrait être très intéressant.
J'imagine l'électricité.
J'ai pas d'idée parce que vu que le chauffage est collectif, donc nous on n'a pas la main sur le fait de pouvoir soit changer d'organisme qui gère le chauffage ou...
Par des chaudières.
Est-ce que c'est possible de chauffer par le gaz ou pas? Ah bah moi
oui, non, moi c'est le gaz.
Moi aussi c'est le gaz du coup.
Moi c'est chaudière, je sais pas.
Alors mon immeuble, moi à l'électricité, mais par contre je ne saurais pas trop vous répondre non.
C'est chez toi donc.
Moi je suis au 10e étage, je suis dans des lits à hauteur et en été il fait très très chaud parce que le chauffage il reste et on peut pas le régler nous.
En privilégiant les dépenses sur, sur la sobriété pour améliorer la performance thermique de l'appartement par exemple. C'est-à-dire attendre vraiment quand il fait froid, pas chauffer trop fort, pas au-delà de 20 degrés.
La première idée moi qui me vient en tête c'est l'isolation, la rénovation du parc immobilier en se basant éventuellement aussi sur, alors je sais plus si c'est toujours à date mais les normes BBC ou le double vitrage, effectivement aller à la chasse aux déperditions de chaleur ou autres.
Couper le chauffage quand on n'est pas chez nous, quand on est en vacances.
Du double vitrage.
Ah ouais? Je savais pas.
Le double vitrage, moi j'allais dire double
C'est ça que ça sert.
Moi je savais pas.
On s'habille un peu plus chaudement en attendant les périodes plus froides et puis c'est tout.
En habitant dans le midi où il fait plus chaud, on se chauffe moins.
Aux appareils éco, à tout quoi. Mais enfin, ça, il n'y avait pas besoin qu'ils nous le disent pour qu'on le sache. La facture, c'est nous qui la payons, donc on le sait.
Moi j'aurais dit pour une grande maison énergie solaire, mais je savais pas pour un immeuble.
Peut-être énergie solaire, mais énergie avec des combustibles, je sais plus comment ça s'appelle, mais il y avait quelque chose comme ça.
Dans les grands ensembles, on peut mettre des grosses chaudières. On s'interroge, pour l'instant on est au gaz et la chaudière est fatiguée, donc il va falloir y réfléchir. Donc on fera une étude sur le chauffage urbain et d'autres.
Alors un réseau de chaleur, non, je ne vois pas trop ce que c'est.
Je ne sais pas vraiment ce que c'est qu'un réseau de chaleur.
Un réseau de chaleur, alors je pense que c'est le réseau de chaleur urbain qui permet de chauffer les bâtiments avec des ressources notamment du bois, de récupération.
Alors effectivement, il y a eu des gros travaux sur les chaudières et tout ça, et donc ils ont passé un réseau. Donc effectivement, ce réseau-là, je connais, vu les désagréments que ça a donné, mais on sait pourquoi, pour la bonne cause.
Au réseau de chaleur, je pense à, on va dire au chauffage d'abord dans un premier temps, ou c'est tout ce qui me vient en tête.
No super. Keď sa tak zamyslíme, že ak by sme takýto prieskum urobili u nás, možno ako by dopadol, kľúčové je pre nás, že ako vnímajú a či poznajú vôbec systém ďalkového vykurovania. Možno, že by sme dopadli ako v tomto videu. A nech je aj toto video a viac menej vedomosti o ďalkovom vykurovaní jedna z víziev pre nás tu doma. Ako viac propagovať, ako viac a krajšie robiť marketing, čo sa týka ďalkového vykurovania, lebo v rámci rôznych systémov vykurovania je to ekologické, bezpečné a aj cenovo dostupné vykurovanie. Menej z toho je lepšie, keď všetci šetria, tak potom už nebudeme mať čo kúriť. Takže biznis klesá, ale žijeme ešte v takom podnebí, že ešte máme 4 obdobia. Máme jar, leto, jeseň aj zimu, takže svojím spôsobom spotreba tepla ide od toho, či je zimšie alebo teplejšie. Ja by som na úvod, kým odovzdám slovo pánovi profesorovi Petrášovi, aby celú tú odbornú časť manažoval on, povedal pár slov, kde sa zhruba na Slovensku nachádzame. Úvodom poviem, že systém ďalkového vykurovania sme nevymysleli my, v podstate ich vymysleli naši predchodcovia v bývalom Československu už v 30 rokoch minulého storočia. Na rozdiel od dnešnej doby nemali ani počítače, ani softvery, ale mali zdravý rozum a vedeli už vtedy, že to, čo sa vyrába spoločne, dá sa lepšie kontrolovať, dá sa nasadzovať úplne na technológie, ako kúriť v každom byte. Dnes sme na Slovensku, v podstate máme viac ako 3,5 tisíca kilometrov tepelných rozvodov. Sústavy sú vybudované vo všetkých väčších mestách, dokonca aj v obciach. Myslím, že kúrime asi v 140 miestach na Slovensku. Takže je to dosť. Čo sa týka palivovej základne, zhruba polovicu tvorí zemný plyn. Čo sa týka technológií, viac ako 50% tepla je vyrábaného efektívnej kogeneračnej výrobe. Zhruba 20% máme z obnoviteľných zdrojov. Zásobujeme na Slovensku 761 000 domácností, to vyšlo z prieskumu ščítania obyvateľov pred 3 alebo 4 rokmi. Zhruba 42% obyvateľov Slovenska je dnes vykurované našimi systémami ďalkového vykurovania. Dnešné ďalkové vykurovanie nie je však len o nejakom vykurovaní budov, bytov a škôl, nemocníc. To je dnes už veľmi sofistikovaný nadstavbový systém a preto ďalkové vykurovanie bude v budúcnosti zohrávať ešte väčšiu úlohu pri naplňovaní hlavne environmentálnych cieľov a etablácii obnoviteľných zdrojov v energetike. Ja som tak povedal, že v odpadovom hospodárstve máme tzv. Cirkulárnu ekonomiku a v teplárenstve môžeme povedať, že môžeme mať teplárenskú ekonomiku. To, čo sa deje v teplárenstve dnes, je v podstate od výroby tepla nasleduje reťazec ďalších činností. Výroba chladu, výroba elektriky, obrovská kapacita uskladňovania energie, až po poskytovanie vyvažovacie podporných služieb pre prenosovú a distribučnú sústavu. Je to celý komplex. To heslo, ktoré je u nás, ani 1 kWh tepla vyrobeného nesmie prepadnúť na zmar, musí byť veľmi efektívne využitá. To, čo poskytuje ďalkové vykurovanie, individuálne vykurovanie, nemá šancu. V každom meste, kde sme my, je čisté ovzdušie. Teplo je síce energia, ktorá v našich systémoch pulzuje pod povrchom, je neviditeľná, ale čo sa týka ovzdušia a pohody ľudí, veľmi, veľmi významná. Charakterizoval by som naše ďalkové vykurovanie ako teplo, chlad, elektrina podporky a čisté ovzdušie. Toto je dnes systémy ďalkového vykurovania a chceme ich naďalej rozvíjať. A nech je aj toto naše dnešné odborné stretnutie a podujatie s našimi partnermi z EFIEES pre nás takým povzbudením, že nie sme sami, že Slovensko nie je nejaký ostrov, ktoré má ďalkové vykurovanie, ale to ďalkové vykurovanie je úplne bežné v celej Európe a že sú krajiny, kde sa ďalkové vykurovanie alebo systémy ďalkového vykurovania budujú ako nové. My v podstate budujeme nadstavbu na tom ďalkovom vykurovaní, ktoré vybudovali naši predchodcovia. Želám našim hosťom príjemný pobyt v Bratislave a zajtra také hodnotové stretnutie všetkých členov EFIEES. Ak neviete, tak 3-krát do roka sa myslím, že stretávajú vždy v jednej krajine. Tento rok to vyšlo na Slovensko, takže sme využili ich prítomnosť na to, aby sme si vymenili skúsenosti. Za zväz to mala pod palcom pani Oleníková. Všetky dotazy prosím na ňu a chvály na mňa. Ďakujem. No. Začína tá odborná časť. Ja by som poprosil pána profesora Petráša, aby v podstate jednak nám predstavil speakerov a jednak celú túto odbornú časť manažoval. Je to profesionál, takže predpokladáme, že bude to profesionálne zvládnuté nielen spoločensky, ale aj odborne. Dušan, nech sa páči.
Dobrý deň, pekné popoludne. Dovolte mi, aby som vás taktiež privítal na pôde Stavebnej fakulty, ale ja musím o stupienok nižšie, takže aj v mene katedry technických zariadení budov, ktorá za uplynulých 46 rokov vychovala 1500 absolventov a dá sa povedať, sú to jedni z mála absolventov, ktorí dneska pôsobia, nazvem to, v energetike budov. A keď budem parafrázovať môjho predchodcu, pána Janiša, predsedu Slovenského zväzu výrobcov tepla, tak to sú tí, ktorí dneska sú schopní svojimi vedomosťami, skúsenosťami a znalosťami navrhovať energetické systémy, či už z pohľadu tepla, vzduchu, plynu, čiastočne aj elektrické energie. Takže ešte raz, my sme veľmi potešení, že Slovenský zväz výrobcov tepla práve pri príležitosti toho európskeho stretnutia asociácie Európskej federácie inteligentných služieb prišiel s myšlienkou niekedy pred 2 mesiacmi, že by sme mohli pozvať sem študentov. Ako sami vidíte, najmä tá pravá časť je plná mladých tvári, táto vľava plná, by som povedal, skúsených tvári, ale my sme veľmi radi, keď sme pripravovali túto koncepciu toho dnešného seminára, že sa nám podaril takýto mix. A ja som mal obavu, lebo je tu 90 stoličiek, my tu mávame ateliéry a v tejto chvíli už niektorí ľudia si aj hľadali miesto, aby si mohli sadnúť. Takže vďaka všetkým vám, ktorí ste prijali pozvanie. Ešte keď ďakujem, tak samozrejme pánu štátnovému tajomníkovi, že si našiel čas, ale čo je možno takisto podstatné, tu sedia minimálne jeden generálny riaditeľ a 2 riaditelia sekcií z oblasti teplárenstva, takže páni, takisto vitajte a sme radi, že ako zvyčajne naše odborné akcie podporujete, tak ste dneska aj tu. Ja by som ešte troška, aby som to odľahčil, predtým ako budeme vážne témy mať, zareagoval na to video a na tú anketu. A keď pozerám na našich študentov, tak taká otázka do pléna. Myslíte si, že by ste odpovedali na tie otázky lepšie ako naši francúzski spoluobčania? Kto si myslí, že áno? Zdvihnite ruky. No vidím, že len skromnosť vám nedovolí. My sme ich stiahli dneska z praxe a ja pevne verím, že na tej praxi, kde sedíte vo významných projektových organizáciách, že tieto otázky, čo ste tu pred chvíľou videli, už máte vyjasnené a že možná opačne už aj vydávate nejaké otázky. Takže možná toľko na úvod a je mi potešením moderovať túto sekciu, kde budeme počuť 3 prezentácie cca po 20-25 minút, za čím bude nasledovať panelová diskuzia a to sa ešte počas toho rozhodnem, či ešte jednu extra prednášku, ktorá sa bude týkať nášho projektu STU Low to High District Heating, čiže to District Heating tým voľným prekladom je práve to teplárenstvo alebo diaľkové vykurovanie, takže tu ešte by sme tam my si prihrali trošku polievočku a ukázali, čo my robíme. Takže prvým rečníkom bude pán Tomasz Surma z Poľska, je riaditeľ pre reguláciu a vzťahy s verejnosťou spoločnosti Veolia Energia Poľska. Je absolventom Univerzity AGH v Krakove, následne absolvent Varšavskej technickej univerzity v Poľsku, kde získal aj titul PhD v odbore elektrotechniky a odborné skúsenosti popri univerzitách získal aj v energetických spoločnostiach. V súčasnosti pracuje v energetickej spoločnosti Veolia Energia Poľsko, je zodpovedný za prípravu analýz trhu, analýz vplyvu regulácií na činnosť energetických spoločností a sledovanie vplyvu priemyslu na životné prostredie. Je autorom a spoluautorom viacerých publikácií o energetickom trhu, obnoviteľných zdrojov energie, energetickej efektívnosti, energetickej politike a spoľahlivosti energetických systémov. So, Tomáš, the floor is yours. Please if you would like, you can take this microphone, or also you can, yeah, it is possible to use this one. A bude hovoriť, ako vidíte, o Energii 2.0, ako v modernom svete vykurovania. Does it work? Maybe we can try it. Maybe I can, okay. Basically, you can say, and they will put it. It doesn't work. I think so.
Okay, so thank you very much. Beginnings are not easy. I am very happy to be here with you, and thank you for introduction of me, and you know more or less about me, and definitely I know a little bit about you, and I am sure that every one of you here in Slovakia knows very well what is district heating, what is geothermal, and how is the future. Probably you have your own strategy. And I am standing here with you also with very pragmatic way. I am not trying to teach you. I am trying to share my experience, and I will be very happy if you look at my perspective, my experience, and maybe in future in your research you will take something to you, and maybe you apply here on this university something what is necessary. As Mr. Chairman said, I am responsible for the regulation. Thank you, Mr. Minister, for being here with us. Regulation is the big part of the district heating sector all over the world, and being strictly regulated support system, dedicated tariff system is very important, especially now in the transition system when we are doing a lot of the activities, especially in Poland, to transfer the coal sources into kind of the neutral. If we may go for the next slide. So this is the agenda of my presentation. I will briefly show you how district heating system looks like in Poland, about the targets which are based on the EU, but also on the company level, on the national level. And daily I'm working for the Volia. I was presented, so I will show you some experience how currently is our approach to the district heating system and how we perceive that district heating development and the future is exit. So let's start with the Polish district heating system. Yeah, this is if we may go far, this is the map, and by the color are indicated the countries with the big share of the district heating system. You are on the top of the Europe because the share of the district heating in Slovakia, also Sweden, Latvia, and Estonia count more than the 50%. Poland is also big. We are feeling big responsibility because we are delivering heat by the district heating system for the more than 50 million of the Poles. This is big of the responsibility. Also, in relation to the current cost, which relay and which is connected with the transformation of the district heating system. Unfortunately, everything costs a lot of the money, and final customers are paying for that. And with the rapid growth of the heat tariffs, heat price, is commented very often. With the last few years, when we observed the huge increase of the CO2 price, when we observed the huge increase of the fuel cost, we had in almost every one city discussion with the citizens, with the public about the heat price. Because with this big share of the district heating, the district heating companies and the whole sector is the big part of the Polish economy. I guess that is the same in Slovakia, that everywhere when the prices increase, you have the still and every time discussion with the customers why we pay such much for the heat. This is the structure, this is like the current status of the Polish structure of the fuels. As you can see, because of the historical value, we use the coal for the many years, and still coal in the Poland is the major fuel. Currently, I will show you for the next slide how we are trying to and doing activities to switch off of the coal. As you can see, even with the last 20 years, it was huge decrease in the using of the coal, but still we are far away from the average of the EU. Currently, we are thinking about the switching from the gas, because for the big district heating system, there is no any single solution to switch for something else, but also thinking about the different approach, about the using of the waste to energy, because in the old city, citizens are generate the waste. And taking into account all hierarchic structure, that the first we are reusing of the waste, trying to make the second product with them, but finally on the end stage, there is the part of the waste which can be used for the heating, which can be used for the district heating. In the Poland, we are agriculture country, so very often we are thinking about the biomass, but not only, also the using of the waste heat. And step by step in the Poland, as a general strategy of the Poland and the individual strategy of the companies, we are thinking about the coal exit. We implemented, thinking about me, about the Veolia, implement the strategy to completely withdraw from the coal until 2030. And we are doing the more green projects. Green means using of the sustainable biomass, which is 35, which are fulfilling all criteria, sustainable criteria. Also waste to energy, industrial big heat pumps, geothermal energy, and waste heat recovery. And I will show you for the all project examples what we are doing. And cooperating with the regulator. As I said, sector is strictly regulated, and without support, without understanding by the regulation, all processes is not possible to transforming of the district heating system like we have in Poland, a huge program which is worth approximately 300 billions of the Polish zlotys. This is a huge amount of the money. And about the main drivers for the decarbonization in Poland. This is the EU policy. Definitely, you know probably about that, but the latest package, Fit for 55, with the revision of the ETS directive, with the revision of the renewable directives, energy efficiency, and also what is worth to underline, the building directives. We are on the building directive faculty. Whole district system is the whole chain. When we are thinking about the transformation, we are not thinking only about the generation side. We are thinking about the whole chain, including the buildings. So for us, our areas to increase energy efficiency on the building side, on the consumption side, means energy efficiency on the generation side and less using of the fuels. So definitely, if you don't know, we understand this package as a definite direction for the phase out of the fossil fuels, including also natural gas, what is very important, because we are trying right now to think how to not switch from the one fossil fuel, from the coal, into the second natural gas. So we are trying to also using, I will show you some projects, using, because for the big system is not option right now by the technological, but using as much possible to use the different generation, to go for the second stage, like in the title of my presentation, district heating to zero. Definitely, the aim is to increase the renewable energy. As you know, until now, based on the European directive, only electricity was supported. Package Fit for 55 is the first, stage putting more approach for the using green heat, green cool, and maximize waste heat recovery. This is a second pillar of the future of the district heating system. And important criteria: efficient district heating and cooling system. Currently, almost all Polish district heating system fulfilling this definition thanks to cogeneration. Why this definition is important? This is important for the future development. When we are thinking about the district heating system beyond 2030, we should fulfill of this definition. For us, it means that fulfilling of this definition, we have the access and the trust by the financial institution, because they are not giving us the money for the development if we are not fulfilling of this. And the second, this also means that we will be able to connect the new customers, new buildings. If we are not fulfilling, there is no obligation, and probably customers will go for the individual solutions. So right now, as I said, we are safety because we are based on the high efficiency cogeneration definition, but in the future, as you may see from this graph, increase the role of the waste heat and renewables. So, and as you know, I am presenting, this is the graph to present also the timeline. The arranging of the project take a time. In case of the Polish, with the using of the current infrastructure, this is more than 5 years. So investment which we are running right now will be applied beyond 2030. So right now we are thinking about this fulfilling of the definition. We should be focused of this new technology. So for us, as a whole scope of this regulation means that we should build our system, district heating system for the renewables, using more of the renewables energy, and using of the waste heat from the different approach. And in the next few slides, I will show you the few examples how we are thinking about this development. And just about the examples. This graph presents I'm right now in the Veolia, inside of the Veolia. This is our strategy. We, based on the ETS directive, we implemented inside of the company strategy with the carbon neutrality plan. The plan is to completely withdraw from the coal until 2030 and being neutral in 2050. I know that this, 2050 is far away from us right now, but really right now we are focusing of the 2030. And we are doing such graph presented, timeline starting from the 2023 when we started. As you can see inside of the Veolia, we had a lot of the coal, more than 80% of the coal. Currently, we are very close to the graph number 2 because we implemented some project with using the biomass and gas. So, if I may still, because this is worth to say what we are doing. Right now, we are in phase of the development of the RDF project. This is the waste to energy project. And also looking for the big industrial heat pumps to distribute. And we are thinking in this scope to switch from the thinking about the central unit located in the city to distribute heat generation through the city. Using the geothermal, as you can see in the 2030, using the heat pumps, biomass, and gas unit as a central unit, which be kind of the stabilizer of the production of the heat and production of the electricity for the city. And beyond of the 2030, you are thinking about the new technology. about the biomethane, we have some project with the biomethane because we are thinking that Poland, with the big potential for the biomethane, we assume that there is something like the 6-7 billion cubic meters possible to use from the biomethane. Currently, we are using about the 15 billion from the natural gas. So half of them, or almost half of them, may be used by the biomethane. And we are planning to develop our own project to switch and to blend this biomethane with the natural gas to use more renewables instead of the natural gas. Of course, probably you heard about the hydrogen projects. For us, still at this moment, this is too costly. We did some economical analysis for that, but unfortunately the cost is too high. And also about the small nuclear reactors, this is the future. We are focusing and talking with the manufacturers. We are looking what's going on all over the world. And you know, with this strategy, with the big district heating systems, there is no chance to not use it in the future. But just currently there is no any rules, no any legislation to support. We are currently, you have much more, experience on that. We don't have currently no experience in Poland with the nuclear. And let's go for the projects. This is a few slides about I choose some project. There is a map of the Poland you can see. And the particular dots, this is the localization of the Veolia. We are active in the 70 different cities, small, medium, and also big cities like the Warsaw, Poznań, Łódź. And the first project was started 2 years ago, was supported by the National Center for the Research and Development. And the aim, they are paying for everything. What was positive for us, they announced the tenders with the aim to build the district heating system, which is completely 100% based on the renewables. And Veolia, together with the partner, Energia, presented the concept and we won. The currently project exists. We have the 1 year of the experience of that. And is based basically on the three-stage storage system. The first one is the ground storage. Is the more than 100 holes deep in the ground, more than 120 meters deep. And this is the first stage. We are heating and taking the heat from the ground. The second is, you can see on this picture on the right side, is the kind of the swimming pool but covered. This is the second stage. We are accumulating with the storage the heat in the water. And the second stage is in this building. This is the storage by the heat. And aim was to take experience from that to supply. We are using about the renewables. We are using the PV for the supporting, for the delivering of the electricity for the heat pumps. And we also signed the PPA, like the special agreement about the buying of the green electricity from the grid. So after the 1 year, we have the positive experience that the system was able during this winter to cover the 100% of the heat demand. The system is not big, and maybe for the PhD students, the data are public. So you can see the data, you can see how it was, how we work, how we manage of this whole energy, electricity, and heat during this period. When we started a year ago, during the summer, to pumping, the heat to the ground, and how this storage system was using during the winter season right now. So data are open. If you, after this meeting, see in my presentation, you will see it. The second about the grid, because as I said, for us transformation is not only generation, is the grid. In Warsaw, we are running the biggest district heating system in the EU. more than 1,900 kilometers, 80% of the city is supplied from the district heating system. A few years ago, we are invest for the digitalization. Currently, we are able to monitoring, to manage, to from the remote control reduce and increase the temperature on the particular nodes. And currently, inside of the system, we are using the EU funds for the upgrade to the using of the AI to collect the data, because as you know, AI may be used for the collecting data and to taking exactly what we want to optimize the system. And for that, dedicated upgrade center with the young people. This is all of them are graduated, less than 30 years old. And they are exactly right now the team of the 10% working 24 hours per day, monitoring the work of the district heating system in Warsaw. Let's go, I have that time is limited. The third example is the cooperation. I think that the future of the district heating system is cooperation, is the market coupling. We started cooperating with Volkswagen. This is the project about the waste heat. Volkswagen in Poznań, in the middle of the middle part of the Poland, there is the manufacturer working the cylinder for the cars. The system using a lot of the electricity, and in this process, a lot of the heat was, waste. We go together for the cooperation. Currently, we are using of this waste from the compressors and for the furnaces. And thanks to that, we are delivering the heat for the Volkswagen and also using the heat for the apartments building around of this company. This is inside of the city. And a lot of the workers, employee of the Volkswagen are supplied by their heat. Next project is about the biomass with the aim exactly starting, as you can see in the background, very old heat-only boilers units. We are switching in the cogeneration of the biomass with the aim in the next stage to switch into the small gas units, gas engines, also to working with the electricity grid, because the next stage, in my opinion, is also cooperation to market coupling with the electricity, but I will tell you something in the end on that. And also about the cooperation, last example with the waste industry, about the biogas. This is the project when we are collecting the biogas and using them in the small cogeneration unit. And in next step, we are thinking about the treatment of this biogas and switch them into the biomethane, because as I said, biomethane for us is the kind of the luxury fuel in the future, which may be mixed with the natural gas. And that's all. Maybe just one word about the electricity. As you said, my background is electricity. I am engineer of and PhD from electricity. Currently, also, we are thinking seriously about the cooperation with the electricity sector. With the rapid and huge growth of the renewables energy, wind, PV, mainly in the Poland, they are producing right now unstable energy. During the summer, during the winter, there is the fluctuation of the electricity, and currently there is a huge problem for the operators. Very often they are cutting, so they are wasting of the electricity. For the cooperation with them, we are the great partner, having a lot of the thousands of the cubic meter of the water. We are offering the less expensive storage systems just to accumulate of this electricity, to using the electric boilers, using own sources to accumulate, to working together. And my idea for the future is that we will develop if we will cooperate. And thanks also, I am very happy to be with you, to cooperate with Slovakia. Thanks to Martina, very often when we are going together to Brussels, we are very happy to send one voice from our district heating perspective on the Brussels level and to present our arguments. Thank you for the invitation.
Thank you, Tomasz, for excellent presentation. First of all, what are the main aim for the future given to us from European Union, especially in the different kind of directive and regulations? And I think that also this overview of case studies which representing different possibilities and opportunities, how to use district heating in different fields, building sector or industry, they are very, very successful. Thank you and congratulations to Veolia Poland for such extremely nice case studies. Rád by som teraz privítal medzi nami pana Pascala Guillaume. I am sorry if I am not good explaining your name. On je zástupcom riaditeľa zodpovedný za profesijné organizácie, pracuje v Dalky, ďalšia významná energetická spoločnosť, viac už ako 30 rokov v oblasti energetických služieb a nielen vo Francúzsku, ale v Českej republike, Spojenom kráľovstve, v krajinách Beneluxu. Pôsobil ako generálny riaditeľ spoločnosti v oblasti obnoviteľných zdrojov energie a energetickej efektívnosti. Je v tejto chvíli prezidentom práve tejto Európskej federácie inteligentných služieb a energetickej efektívnosti, ktorá tu má zajtra pracovné rokovanie a takisto členom predstavenstva Združenia Euroheat and Power so sídlom v Bruseli. Je taktiež prezidentom FEDENE, Francúzskej federácie služieb energetickej efektívnosti, ktorá združuje viac ako 500 členov a ktorých spoločným cieľom je práve dekarbonizácia vykurovania prostredníctvom obnoviteľných zdrojov a odpadového tepla. Tieto spoločnosti v Francúzsku generujú ročný obrat v objeme 11 miliárd eur a zamestnávajú viac ako 60 000 ľudí. So, Pascal, the floor is yours, and I would like kindly ask you for, I don't know how it will be presented in English, but in my Slovakian translation is introduced francúzske recepty na udržateľné a dekarbonizované teplo. What does it mean recepty? Do you have it? Môžete to kliknúť v angličtine? Okay, it means that it will be not only the kitchen, but also the measures how to save energy. Welcome.
Ďakujem pekne. Right, so I'm delighted to be with you today at this conference in this gorgeous university. I will speak as the president of the French Association, and what I will say is not that much about technical issues. I know that there are many knowledgeable persons in this room, some of them much more expert than I could be on district heating, so it's more about policy and the way we in France see this wonderful sector that is district heating. Can I have the next slide, please? Thank you. So first, a few words about FEDEN, which is a French federation. We've been in existence for more than 80 years. It's altogether 1,500 businesses across the whole of France, 50,000 professionals who are working in two main professions of the energy transition: energy efficiency, reducing consumption in buildings, collective housing, tertiary buildings, schools, hospitals, swimming pools, but also obviously in the industry. And the second profession is production of renewable heat and cooling. As a federation, obviously our purpose is to represent our members, industrial players in this field, in discussions with the French authorities, contributing as stakeholders to shaping the regulations. It's also promoting what we see is the best way to reach this carbon neutrality that we are committed to reach all together as Europe in 2050. Still, being a federation has also two other missions. For us, we are also a sector, a business sector. So we are negotiating collective agreements for our sector. And last but not least, we are promoting our activities and trying to shed some light on what is not really known. You've seen from this film, most of the people don't know our activities, don't know that if they want to contribute to enhancing the climate, changing against, fighting against the climate change, there has to be talents attracted in our activities. So it's part of our responsibility to make it known and attract the right talents. And I know that there are a few ones in this room. So, heating. There is something that is quite obvious. When you mention the word renewable energy, most people, because there is a semantic confusion, think renewable electricity. So, solar panel, wind turbines. Heating is, in France, 43% of the energy consumption. It's the biggest energy consumption before transport, before electricity. And 60% of it is produced from fossil fuels, almost all of it, at least the bulk, from natural gas. So, talking about decarbonization, talking about climate change, the issue definitely is how do we decarbonize heat? Besides, in France, we are a country where electricity is almost already decarbonized because it's heavily produced from nuclear power and hydraulic, so almost no thermal production, but for some cogeneration, which have another value. So, district heating, you know very well what it is. I won't dwell on that. I guess the main message about what district heating is bringing is that it is a heat aggregator. You want to decarbonize heat, you get all the needs, you aggregate them, you bring them to a place where you can make the best use of the local resources. So, whether it's waste heat, whether it's biomass, geothermal energy, thermal solar, you have to aggregate it to be able to decarbonize it efficiently. This is the first vision that we have about what brings district heating. But it is also something that contributes to the local economy. To develop district heating, you need investment. There is a study that has shown that the main mechanism to support development of district heating in France is called the heat fund. It helps investing in expanding or creating new district heatings. And for €1 of public support given, there is anything between 3 to 4 euros of local investment. It means local economy and also local jobs. I said it, we see district heating as a key tool to decarbonize heat. What you see here is the history over the past 10 years of the carbon content of the district heating in France. So direct emissions or life cycle assessment in blue, it's a constant trend to decrease the carbon content, and we almost divided by 2 the level of emission for each unit of energy consumed over the past 10 years. How did we do that? We moved from 30% of renewable and waste heat content in 2009, and we reached 66.5% in 2023. Constant investment, And what is, at the end of the day, the market, the energy blend and the energy mix of the district heating? 30% of waste heat coming from waste to energy, bearing in mind that half of it is bio-content, more or less. 25% of biomass, a bit more than 5% of geothermal energy, a small content of industrial waste heat. And I'll come back to that because this is something that we have to strongly develop. Some other renewable energies, heat pumps, for example, mostly on geothermal energy, and these 30% of natural gas that we need to remove before we reach 2050. So 30%, 66.5%, and we aim for more in the coming years. Another feature of the district heatings that I'd like to really underline. District heating is a tool for a resilient energy supply in many dimensions. You probably know, for the ones who are interested in the EU regulation, that EU is currently strongly focusing on how can we make sure that most of our utilities, most of our public services are resilient to incident, resilient to aggression, cyber attacks. District heatings, by their very nature, are resilient. They are using more than one energy, mostly. You see here that 90% of the heat supplied by the French district heating is produced in a district heating where there is more than one primary energy involved. 3/4 by district heating where there is at least 3 energies, and quite often on more than one production site. So technical resilience. And those district heating increasingly are interconnected, which adds further resilience. On the right-hand side, you see how it also translates in terms of financials. Following what happened in Ukraine, there was a heavy energy crisis, and fossil fuel prices rocketed. You have here 2 curves. The green one is what happened or should have happened without any corrective measures in terms of energy prices for district heatings. This is the average price for a dwelling. And the brown is a standard central gas boiler for a housing building. So you can see that prices in district heatings were way more stable for 2 reasons. Because in the price content, this investment, and the second is that renewable energies don't follow the same pace when it comes to pricing. And the dotted lines are what happened after the French state put in place some shielding measures for consumers. So still, district heating remained way more competitive during those very difficult times. Hence the fact that in France, everybody discovered that renewable energy is fine for climate, but it's also way more resilient in terms of prices, so we should develop more. And hopefully this is what will happen. There is a say, what is small is beautiful. In that respect, the market share of district heating in France is very beautiful, because it's only 5%, unfortunately. We are far from these 42%, I think, I heard, in Slovakia. Lucky you, we just have 5% of market share. Still, we've been relentlessly creating district heatings, connecting buildings, and last year, we listed 1,000 district heatings of various size, of various nature, but still 1,000. And the connected buildings moved from 30,000 in 2013, and 10 years later, it's 50,000 connected buildings. So a steady growth, but far from what we want for our sector. So now, what is the vision of the French state? The French legislators, the government? Well, they are deeply convinced that district heating is a wonderful tool to match, as I said, heat demand and resources from the local resources everywhere in various areas. And they are of various nature. So their plan is to double the market share of the district heating between 2023 and 2030. Huge step. And to be honest, they have been rocketing for the past 3 years. And the aim is to reach 90 terawatt-hours coming from 30, so times 3, in 2035. Bearing in mind that energy efficiency will also have reduced energy consumption of the building. So it's more or less quadrupling the market share of district heating. This will also be done by increasing the share of renewable energy and moving, I said, 66.5% in 2023. We have committed to reach 75% in 2030, and we aim for 80% in 2035. So more or less getting there when it comes to reaching carbon neutrality. So how can we go faster? Geothermal energy is really something that has a priority currently. When we are investing in energies, there is what we call merit order, and geothermal energy is one of the priorities for the French authorities. We have 3 main regions where it's available readily. Northeast of France, Paris region, southwest. There are already a number of district heating, as you've seen, using geothermal energy. More should be done, and a plan was launched to investigate the resources in the underground and see how we can maybe know more about what is available and develop it further. One thing that is really making it difficult to develop district heating is the way French apartments, collective apartments, are heated. What you see here is a pie chart that shows the more or less 30 million housing in France. A bit more than half of it is individual housing, so not that much a priority target for district heating. Then 45% is collective housing. Out of these 45% of collective housing, just 1/3 is equipped with central heating, so readily connectable to district heating. The rest, it's individual. If you zoom, you see that more or less half of it is gas, half of it is electricity. So if we want really to develop the renewable energies, it's true for district heating, but if you want to have heat pump or biomass boiler for a building, you need to centralize the heat demand. So what we are negotiating with the French government is a stronger support when there is a building renovation to move from individual solutions to centralized heating, because this is where you bring the energy flexibility. Waste heat recovery, fundamental. There is a huge potential in France. For the time being, industrial waste heat is 1% of the energy mix of the district heating, so more or less 360 gigawatt hours. There is 100 terawatt hour of unused fatal heat on French industrial sites. Half of it being above 100 degrees C. So you see this huge untapped potential. So we are working on it, and we are also trying to push forward a mechanism that will allow this project to fly. What is the issue? District heating, economical lifetime, you invest, return are to be expected within 10 to 15 years. Industrial site, your horizon is you can commit up to 3 years, sometimes 5 if it's process. How do you match those two realities? Because if you invest on a 10 or 15 year time span, who is going to take the risk that the industrial site close down? We are advocating and trying to set up with the French authorities the risking mechanism that will allow this project to fly. So these are some of the regulatory measures that we are trying to push to further develop. I think I lost one, but can you?
This is the next slide of the presentation.
Can you go back? I missed this one. I jumped on it, so, but I'm coming back. So some of the regulatory supportive mechanisms that are in place. In France, if your district heating is above 50% of renewable and waste heat, more than 50% decarbonized, if you build a new building or if you refurbish a building within a priority area, you have to connect to district heating. Unless you can prove that you can have a better solution, which means more environmentally friendly and less costly. So, by definition, you are in an area where district heating has been set as the priority solution, you have to connect. I mentioned the heat fund, strong support. In a few years, the budget of this supporting mechanism went from 300 million to 800. So 60% of it is for district heating, the remaining 40% being other renewable projects. And last year, you probably know that public money is scarce in all countries. It's very true in France. Despite the budgetary crisis, the French government decreased a number of supporting budgets, but this one has been left unchanged because it's really perceived as the best return in terms of public support. And last but not least, we also have a reduced VAT for those what we call virtuous district heating, meaning almost decarbonized. Jump another two. That's it. What about cooling? Because we always see in documents district heating and cooling, and most of the people forget very easily about district cooling. This is something that we consider in France as not only being efficient for preventing the climate change, but also for climate change adaptation. It's more efficient. One of the key issues when you have individual solutions is how can we contain refrigerant fluids, and you know that their global warming power is way above CO2. So these centralized solutions are much better, and they also avoid to reject in the atmosphere the heat. What you see here is a schematic of the Lyon district cooling, one of the plants. How does it work? There was a car park, which goes across a few water tables, the low one and the higher one. So it was potentially flooded, so they are pumping out the water. Rather than throwing it in the upper water table, they use it for producing cool. And as importantly, they are using ice storage to address one of the key challenges that is ahead of us. How can we stabilize our electrical networks with prices that go from very high to negative prices? So peak demand is going to be a challenge, and district cooling can also contribute to that. And as you can see, the vision for French authority is, again, to triple the market share of district cooling between now and 2035. So, in a nutshell, district heating or district cooling is considered as one of the answers, if not the answer, to address decarbonizing heat. Thank you for your attention.
Thank you. Thank you for very interesting informations dealing especially with energy efficiency in France using the district heating system. And also I would like to stress your attention to the subject which was presented at the end is the new subject. It is entitled district cooling. And I am maybe announcing that I think in the very short time we should also try to apply district cooling system also in Slovakia. Now it's my pleasure to welcome the third speaker. It's Mr. Francisco Silvero Marquez. I hope that it is not so bad. My pronouncing. Ja by som zmenil teda jazyk. Jedná sa o senior viceprezidenta pre energetickú efektívnosť budov zo spoločnosti Veolia. V jeho príspevku budeme hovoriť o dekarbonizácii miest vďaka energetickej efektívnosti i s pomocou artificial intelligence, čiže umelej inteligencie. Pán Francisco pochádza z Portugalska, je vyštudovaný stavebný inžinier, architekt. You are on the right place with your
Absolutely.
education.
I'm home.
Yeah. Začínal riadením projektov pre architektonické európske firmy. Od roku 2005 pôsobil v energetickej divízii spoločnosti Veolia. V rokoch 14 až 17 ako riaditeľ pre rozvoj podnikania a marketingu spoločnosti Enova v Dubaji a neskôr bol riaditeľom širám Veolia v Taliansku. Od roku 2020 vedie segment energetických služieb pre budovy v parískej centrále Veolie, kde podporuje krajiny celého sveta pri strategickom plánovaní a realizácii riešení energetickej efektívnosti budov. So, Francisco, the floor is yours.
Thank you very much. Thank you for the introduction. The 4% challenge. Are you familiar with this challenge? The 4% challenge? We'll do like in the movie. Who has already heard about the 4% challenge? No? So it will be a surprise for all of you, or maybe not. The 4% challenge is actually what we need to achieve in terms of energy efficiency 1 year after the other if we want to reach our zero carbon targets by 2050. And it is a challenge because we are coming from, does this work? I'm afraid this doesn't work. Doesn't work. Yeah, exactly, thank you. We are coming from historical figures of around 2% energy efficiency year on year, and we need to double that immediately and to sustain it until at least 2030 in order to achieve our targets. It's not just me saying that, it's the International Energy Agency. It's part of the stocktake of the COP28 of last year that we need to double these energy efficiency efforts. Now, it seems easy or not easy. We could say it's only 2% more. Actually, how is that figure built? Energy efficiency year on year is the difference between the GDP growth, so the economic growth that we have in our countries, and the energy consumption growth. So when we have 2% energy efficiency, it means, for instance, if I take global GDP growth of 3%, 2% energy efficiency means energy grows by 1%, GDP grows by 3%. Now we are starting to see why it is difficult, because if my GDP growth is at 3, if the energy efficiency is 4, 3 minus 4 is minus 1. Which means that it's not only that the energy consumption should grow slowly and more slowly than the economical growth, it means that the energy consumption should be reduced. And we see that the challenge here is already a little bit different. And why do we need that? Well, first of all, we need it because we won't have enough resources for renewable energy to be on the track for carbon neutrality with just renewable energy. We need to reduce the energy we are consuming. In the COP28 stocktake, it was essentially for environmental reasons. But it's not the only reason. The other reason when we start seeing that is reducing our energy consumption also gives us more energy security because it reduces our need to import fossil fuels from other regions, from other countries. And the third reason why it is important is because of the way the energy pricing is built. You know that we always start with the cheapest energy, and then when demand increases, we go to more expensive energy sources. So if we reduce our energy consumption, not only do we reduce the volume, and therefore what we are paying for the energy, but we also reduce the tariff, because each megawatt hour or each megajoule costs us less. So it's a double lever on the energy affordability, and that's why energy efficiency is also considered in the Affordable Energy Act that was published by the European Commission. So we need to go from these 2 to 4%. But actually the news is not very good, and that's the last part of this slide. In 2023 and 2024, we reduced our energy efforts from a historical average of 2% to 1%. We are doing worse. We are not doing better, we are doing worse. So okay, 2020, 2021, it was lower, but it's because of the COVID crisis, so the economy was not growing, and because we're always talking about the difference between economic growth and energy consumption growth, it did not work very well. 2023 and 2024 is bad news. It's bad news. It means that we are not on the right track. So the question is, why are we stuck? There are 3 reasons. First of all is a technology reason. And that's why I'm very happy to be with you here today, because collectively we can find a solution for these technology reasons. I would put it very simply. Let's talk about buildings. All buildings are different. So it is very complicated to have a large-scale operation on energy efficiency without checking every single building and understanding what is its energy consumption, having an energy audit, identifying energy conservation measures, because each building is unique. So each time you need to start it again. That's the first reason, technology. Second reason is about finance. When we invest in producing more renewable energy, it's quite easy to have a good vision or a good view on the cash flows of the project. We know we build a certain area of PV cells. we know how much is produced, we have all the statistics, and so we know what our revenue will be. For energy efficiency, it's a little bit more complicated because it's not a direct revenue. Actually, the cash flow is less negative, less expenses. I'm not talking about increasing my revenue, I'm talking about reducing my expenses. So it's a little bit more tricky to have it work within a business model. And then the third reason is something more psychological, a matter of communication. It's very easy to cut a ribbon on a PV field or on a new dam for hydroelectricity or on windmills. It's very complicated to put a ribbon on energy efficiency measures. Efficiency is something we don't see. Again, it's something less, it's not something more. So we need to overcome those obstacles. And I think the first thing to do is actually a mind shift. I think it's quite interesting that this presentation on energy efficiency comes as the last one. Why? Because we are talking about the value chain of energy. We've all learned about the value chain of energy: production, distribution, usage. That's the mind shift we need to have. We're not talking about the value chain of energy. We are talking about the value chain of energy efficiency, of the energy we don't consume, of the negative energy, if you want. So we need to shift that value chain around. We create value by reducing our demand. And then we make the distribution more efficient. And then we make the production more efficient. And that's why starting with reducing the energy demand in buildings, in industries, is what will enable us to have our district heating and cooling networks even more efficient. Because we start by optimizing the buildings, we start by only using the energy that we need, and then we optimize the way it is distributed, we optimize the way it is produced. And it works. And we have the opportunity, as you see on next slide. Because actually it's an amazing virtuous circle. We start by implement energy conservation measures. In the buildings, in industry, we reduce the demand. Once we have done that, obviously we will reduce the energy volume. And this brings all the benefits that we are talking about. Benefits of less pollution, benefits of less emissions of CO2, benefits of less costs, obviously, benefits of more energy security, as we were mentioning, pure air in the cities. All of those are benefits. But that, we reduce the energy costs. So you're starting to see how all of that is a virtuous circle, because not only we are doing good, but we are doing it well. And the beautiful thing of that is the fourth part of the circle. With those reduced energy costs, we have money to invest in further implementing energy conservation measures. That's a beautiful virtuous circle that can answer the challenge of finance that we were talking before, because actually we can find players who are interested in putting money here because they see it is a virtuous circle that will always create more value. It solves the challenge we had on communication because it brings benefit to all. So yes, it's not as easy to show as an energy plant, but it brings actual benefits to all that everybody can see on their energy bill. Does it solve the technology problem? Not quite. And that's where we have a game changing now with artificial intelligence. That is the game changer that we have today that will enable us to overcome these technology challenges. Why? Because artificial intelligence will enable at least, sky's the limit, but at least 4 things. The first one, better analysis of the buildings. Through artificial intelligence and its capacity to analyze big data coming from everywhere, we will not need to do a single energy audit on each and every building, but just based on data that is available through the utilities company, data that is available in the town hall registers, the age of the building, the area of the building, the type of energy it's using, the benchmark we do against other buildings, we can very easily identify energy conservation measures that can be implemented at a large scale. So we are going from bespoke projects to large-scale projects where we could refurbish a whole city without actually having to look into each and every building to find what are the most appropriate energy conservation measures. That's the first thing. The second thing that we can do with artificial intelligence, and this one is quite obvious, is to optimize. Once we have implemented the energy conservation measures, we can manage the buildings, we can manage the industries in order to ensure that we are only using the energy that is necessary. If you remember the first chart I showed you with those 2 years of COVID, what did that mean actually? It meant that even though many of our buildings were not used, we were still using energy in these buildings. We were still using energy that was not needed. In France, in the offices during lockdown, 60% of commercial companies didn't see any reduction in their energy bill, even though the offices were empty. And I have the figure for France, but I'm sure it was the case in many other places, because our buildings were not ready for that optimization. Today, thanks to artificial intelligence, they can be. We know exactly what is the usage, and we know exactly how to adapt the energy production to that. And actually, it's not just that we know what the energy need is that we can predict what it will be. Based on weather algorithms, based on the historical behavior of the building, we know that this is a university, maybe there are some classes during the weekend, maybe not, maybe it's just 1 weekend out of 3. Well, all of that historical data will build patterns of the energy consumption in the building so that we can adapt the energy production to what the need will be, considering the inertia of the building, to adapt it exactly to what we need. And then the fourth thing that we can do with artificial intelligence is command, automate, operate the building from a central command center. Tomasz was talking about our upgrade centers. That's exactly what we do. We control the buildings from a central remote center, where we will change the settings in the buildings in order to adapt to everything else that those algorithms gave us. What is the need? What would it be? So let me change the settings now. And with that, we can overcome that technological challenge of every building being different, everyone needing some different and specific energy conservation measures. We can standardize much more and get to this wide scale. A few examples of things that we have done. I'll start on the upper right-hand side of the slide and go clockwise, not very far from here in Prague at Bonice Hospital. It's a project that illustrates how we can combine artificial intelligence with actual energy conservation measures implemented on site. Maybe some of you know this site is the typical hospital from the early 1900s, an architecture of pavilions within a park, actually connected to Prague's district heating network. The thing is, there was only one substation in the hospital, and so you only had one single internal network going through all the pavilions. So you can imagine how inefficient that was. So what we did is we built an internal network with substations in each of the buildings, which is already something good. But in order to ensure that that could really work, we added two things. First of all, we did some insulation on the buildings. We insulated the roofs, we changed the windows in order to reduce the demand. First step, energy efficiency first. And then the other thing that we did is that we installed IoT in all the buildings in order to manage each of the substations, I'd say in a smart manner, so based on the demand, and to optimize the internal network to reduce the energy consumption. And that is also sent to the Hubgrade 4 Prague network, so that we really optimize the energy that is distributed on the site. With that, we could reach 30% energy savings, which, considering the type of building, was significant, and with a very good payback for both the customer and the investor, in this case, ourselves. Another example that is very interesting also is the city of Milan, because here the difference is we had 1,200 buildings where we needed to reduce the energy consumption. And our commitment was 25% reduction on the energy bill for the city of Milan. Historical buildings, modern buildings, theaters, offices, schools, sports centers, you name it. And here this approach of combining energy conservation measures implemented in a few specific sites, but mostly the remote controls on all these sites enabled us not only to achieve the 25%, but even to overcome it. And today we are between 25, 30, sometimes even 35% energy savings on a very, very, very wide range of buildings. And the last one, the last example, even though it's not in continental Europe, but still not very far from here, in the south of UK, in Eastbourne Hospital, again, a combination of refurbishing the facade, here what you see is the new facade, and replacing all the energy production equipments. Now, why is this interesting? Because with the reduction in the demand that we could reach through the refurbishment of the facade, we managed to get to a level of demand that could be provided through heat pumps. And so we got rid of all the gas boilers in the hospital. Actually, we kept one for resilience in case there is an issue, but we can, with the demand that the hospital has today, we can provide all the energy that is needed for the hospital just through heat pumps. And where does the electricity for those heat pumps come from? PV field that we installed on the roof and in the car parks in the hospital. And this today can very well be the first zero-carbon hospital. Because by bringing together the action on the actual building and replacing the energy production and the energy sources, all of that managed through artificial intelligence, we can get a zero-carbon hospital. Again, that's why I'm so happy to be here today, because I think as a civil engineering faculty and also building systems faculty, you have everything to bring together what is needed for this mind shift. And that's what will enable us to go to this tomorrow zero carbon cities, where this artificial intelligence or just digital network will enable us to properly manage the demand, to refurbish the buildings, to implement energy conservation measures, reducing the demand in the buildings, optimizing the distribution, optimizing the production, and using all the levers that we can have in the district heating and cooling networks that my colleagues showed to you before. Thank you very much. Thank you.
Again from Veolia, but coming what I mentioned before from Portugal and graduated in our civil and architecture branch, and it's my really pleasure to see how artificial intelligence, I hope, will change our world to the better. Teraz by sme prešli ešte na jednu prednášku, ktorou by sme si radi prihliali polievočku aj my tu na našej fakulte. A ja by som si dovolil pozvať sem k mikrofónu inžinierku Martinu Mudrú, našu doktorantku, ktorá je veľmi aktívne zapojená do projektu Low to High District Heating a v takej krátkej ukážke by sme vám chceli ukázať, ako v súčasnosti sa aj na Slovensku postupuje pri tzv. Dekarbonizácii a práve zmyslom toho projektu je v zdrojovej časti sústav centralizovaného zásobovania teplom nahradiť fosílne palivá obnoviteľnými zdrojmi energie. Takže Martinka, nech sa páči.
Dobrý deň, ďakujem pekne za slovo a som rada, že vám môžem povedať zo pár slov o tomto našom medzinárodnom projekte, ktorého sme súčasťou. Slovenská technická univerzita v spolupráci s Európskou agentúrou pre klímu, infraštruktúru a životné prostredie podpisom grantovej dohody vlastne participuje na medzinárodnom projekte s názvom Low to High District Heating. Tento projekt je spolufinancovaný zo zdrojov Európskej únie v rámci programu LIFE. Cieľom tohto projektu je podporiť približne 30 vysokoteplotných sústav centralizovaného zásobovania teplom na Slovensku, v Poľsku a v Litve v procese zavádzania nízkopotenciálnych obnoviteľných zdrojov energie, akými sú solárna tepelná energia, geotermálna energia, energia prostredia a tepelné čerpadlá a taktiež technológií spätného získavania odpadového tepla do sústav CZT. Projekt je trojročný a aktuálne sa nachádzame v jeho polovici. Prečo práve Slovensko, Poľsko a Litva? Ide o krajiny, ako už bolo v úvode povedané, kde je podiel tepla dodávaného do domácností prostredníctvom sústav CZT veľmi vysoký. Na Slovensku je to zhruba 53%, v Poľsku 42% a v Litve 56%. Zároveň je v týchto krajinách veľmi vysoký podiel fosílnych palív. Na Slovensku dominuje zemný plyn, zhruba 91%. V Poľsku, ako pán Surma povedal, je to spaľovanie uhlia 86%. V Litve je to čosi menej práve vďaka spaľovaniu alebo používaniu biomasy v sústavách CZT. Ide o medzinárodný projekt a teda účastníkmi projektu je španielská konzultačná a poradenská spoločnosť KTORÁ, ďalej bulharská poradenská spoločnosť Europrojekt, španielská finančná investičná poradenská spoločnosť GNE Finance, poľská poradenská spoločnosť KP, litovský energetický inštitút LEI a dve talianske univerzity, Univerzita v Janove a Univerzita v Neapole a v neposlednom rade my, Slovenská technická univerzita v Bratislave. Aké sú naše očakávania po 5 rokoch od skončenia projektu? Je to hlavne úspora primárnej energie, nahradenie energie vyrobenej z fosílnych palív energiou z obnoviteľných zdrojov, zníženie emisí CO2 a zároveň spustenie investícií do udržateľnej energie. Ako už pán profesor spomenul, cieľovou skupinou tohto projektu sú sústavy centralizovaného zásobovania teplom, ktoré spaľujú fosílne palivá a majú záujem o integráciu obnoviteľných zdrojov energie do týchto sústav. Našou úlohou je vlastne poskytnúť podporu týmto sústavám CZT v rámci technického a investičného plánu. V prípade vášho záujmu o tento projekt môžete navštíviť webovú stránku, ktorú vidíte na plátne. Nájdete tam rôzne aktuality a novinky týkajúce sa projektu a môžete osloviť aj nás priamo dnes. Ja vám ďakujem veľmi pekne za pozornosť.
Ďakujem kolegyni inžinierke Martine Mudrej za aspoň ukážku, že aj na našej univerzite sa uvedenou problematikou vážne zaoberáme a ja som potešený práve, že sme boli spolu aj so spoločnosťami z Poľska, Litvy vybraní na určité promotion týchto aktivít na Slovensku. Now I would like very kindly thank you to all speakers in this first part of our seminar. We will follow with the open discussion or panel discussion, and before I will do it, I would like kindly introduce the very important woman who is the only one sitting in front of you. And je mojím potešením privítať medzi nami pani Valériu Pleinemeissen, welcome, ktorá je generálnou tajomničkou práve tejto Európskej federácie inteligentných služieb o energetickej efektívnosti. Ona dneska nemá prednášku, ale bude súčasťou tohto panelu. Valéria je veľmi, veľmi skúsenou, dá sa povedať, administrátorkou v politikách Európskej únie. Dlhé roky pôsobí v rámci Public Affairs Európskej únie, má skúsenosti z oblasti cirkulárnej ekonomiky a energetickej efektívnosti a veľmi dobrý prehľad o potrebách a výzvach energetického sektora. Takže týmto by som ukončil tú časť prednáškovú a máme ešte 15-20 minút, ktoré by sme mohli využiť na panelovú diskuziu. V panelovej diskuzii, in the panel discussion, I would like again kindly ask all previous three speakers, also Valerie and also Stano, the representative of our, how would say in English, the Association of Production of the Heat, something like that. A môžete využiť slajdo, takže už tu vidíme prvé otázky. Teraz sa spýtam tlmočníkov, budete to vytlmočiť, alebo ja to nejak voľne preložím? Vy to budete, dobre. Takže prvá otázka od pána Urbana zo spoločnosti Eco Urban Group Skandinávia. Ako ste prichystaní na Slovensku, v Poľsku a vo Francúzsku na systém ETS2 v budovách a doprave, ktorý by sa mal spustiť od 1. januára 2027. I would like kindly ask you for very short answers. Stanko, môže začať? Aha, dostaneš.
Ja budem veľmi stručný, lebo my neprevádzkujeme budovy, ale teda časť našich spoločností má aj správu budov. Pre systémy ďalkového vykurovania toto znamená také, by som povedal, narovnávanie vzťahov medzi individuálnym vykurovaním a ďalkovým vykurovaním. Totižto naše zdroje na 20 MW sú v systéme ETS1 a už dnes v podstate platia uhlíkové povolenky, alebo nazvime to uhlíkové clo. Ku každej megawatt-hodine plynu musia priradiť adekvátny počet tón uhlíka a zaň zaplatiť. To, čo sa bude diať od 1.2., tak v podstate každý jeden, kto kúri plynom alebo kúri fosílnym palivom, v podstate mu jeho obchodník s palivom alebo jeho dodávateľ paliva k cene plynu, u nás teda druhej väčšine k cene plynu, bude pridávať aj cenu uhlíkovej povolenky. To značí tie nožnice medzi spotrebiteľom naším a spotrebiteľom v podstate individuálneho vykurovania sa tým trošku zmenšia. Nie je to dobrá správa, preto lebo dnes cca ten uhlík megawatt-hodine plynu robí 15 až 20 eur. To značí, ak si kúpite plyn za 40 eur komoditu, pozor komoditu, tak si k tomu prirátate 15-17 eur uhlík a máte plyn za 55 eur.
Ďakujem za stručnú odpoveď. Poprosím Tomáša from Poland. Did you understand the question? Very brief answer. Okay, you can follow.
This is the France. Yeah, let's go.
Yeah, it's okay.
I guess, as I explained, the best way to prepare to ETS2 is to decarbonize, basically. And it's the purpose of this mechanism. Looking at the French experience, we are still, from the government side, working on how to implement it. But a significant part of the district heatings until now were already in ETS 1. So to some extent, it's just adding to the fairness of the solution, because there was an unbalance between a building that was connected to a district heating, already half decarbonized, that was paying for ETS 1, when another one just fed with pure natural gas wasn't. So to some extent, this is tipping the balance in the right way by setting what we believe is right. Carbon has a cost, it doesn't always have a price. So for the time being, we are assessing the impact. There will be an impact for all the district heatings that are below the threshold of ETS 1. But in France, if you develop a new district heating, you don't get support unless you're above 65% of renewable and waste heat. So if you're not at least 65% decarbonized, you don't get any support. So anyway, I mean, for district heating, it's rather something that will enhance the competitiveness of the solution than be a threat.
Okay, thank you, Tomasz.
Yeah, thank you for the question. The ETS2 for the Poland is the critical. As you know, there is a threshold of the 20 megawatts. And even I will add that the Commission right now, they opened the revision program, consultation program from the ETS1. And one of the elements which was put on the agenda by the Commission is to decrease of the level, this threshold of the 20 thermal megawatts. So most probably the Commission is aiming to reduce of this threshold. For us, I am completely agreed with the Pascal that ETS for the energy, for the district sector can be opportunity, because we are running of the programs related to the decarbonization, and in the future we may be more competitiveness. Also, ETS2 is the wider treatment. This is not only for the district heating, it's not only for the energy sector. We in the company offering of the business model for the cooperation for the end customers not connected to the grid, and currently in majority they are using the coal or the biomass or the natural gas, and we are also able to deliver them the solution to skip to switch from the ETS completely to offering them, you know, the green solutions.
Okay, thank you. The next question is going to Francisco. Did you get translation or?
I think I need a translation.
Okay. It means, what are the most often used challenges for implementation of artificial intelligence in the building system or energy infrastructure?
The challenges?
Yeah.
Okay. Yeah, it's a very good one. Thank you. I think actually the challenge get back to the same technology difficulty we were mentioning before. Again, that all the buildings are different. So how do you really act physically on the building? What we are seeing today, and actually we are going that route, is a very modular approach, and we don't think we should consider a single system to do everything. And I think it's interesting to have modular approach. On one side, the field devices, so everything that relates to the connection to the building, to the industrial site, to the network, and where it can be very flexible, provided that you have one single protocol. And these field devices should at least take information, but also, when needed, act on the equipment. Then you'd have a second layer, which is the data management layer, in technical terms, a time series platform, so where you can collect all the data, start processing it, start assessing its quality, repairing it, already have some level of reporting in there. And actually, the interesting thing about those time series platforms is that today they are, I would say, still quite basic. But here as well, artificial intelligence can help you navigate through that data more easily, and already started giving you some reporting in really natural human language. And then you'd have a third layer where you can have the specific applications where you can introduce your own algorithms to optimize the energy consumption, to predict the behavior. And so I would say actually, the challenge would be to consider everything as just one product. The most flexible way to do it and to get benefit of everything that is changing now is having this more modular approach. And we believe in this 3-stage, so connection to the building. And again, because every building is different, and that's the main challenge, you can have very simple systems for very simple buildings, and then more complex ones for buildings with BMS's, building management systems, that can all connect to this time series platform.
Okay, thank you. The next question to Tomasz. Very brief in translation.
I know.
You know,
Yeah.
okay, because you can Slovak, fine.
As I said, also was mentioned in your presentation, energy efficiency is the first. I think that we have a lot of the opportunity for the energy efficiency increase, and this is our future. And about the different technology in generation, as I said in my presentation, the future is based on the 2 pillars, renewables and the waste heat. In Poland, different approach in the big systems, I mean with the capacity more than 1,000 thermal capacity installed generation, and different approach for the small, like medium, small size, 100 megawatts installed capacity. We believe that in Poland, with the agricultural country, the biomass, the biomethane is the future in case of the generation. Also, right now there is a huge program about the electrification of the district heating system. We observe in Poland huge, enormous development of the PV. It started 5 years ago from the scratch, from the nothing, like the few megawatts. Currently is more than 11,000 of the megawatts installed only in PV. In case of the wind, we are currently more than 12,000 of the 12,000 megawatts installed capacity. And Poland is currently investing in the offshore, additional 6. And as I said, the consumption side is only one, limited to the current state of the economy. And with the cooperation, with the taking of the surplus of this electricity, you can use it in the heat pumps, big heat pumps, with the electrical boilers. And I believe that we are starting to working on the program right now, and it can be extended as the final solution beyond 2030.
I will add one more question, but not so polite, which is just now introduced here. What's the transformation of district heating in Poland because big dependence of on the coal?
But you mean right now or beyond 2030?
Yeah, it's better if I see 20% during the last 20 years, but still 60%.
Yeah, it's like that. But right now, really, I'm inviting you, all of you, to the Poland to see that really we are working. I mean that a lot of the projects are right now in the kind of the commissioning stage. Just what we did, we invest, it was also noted by the government, too much in the gas. So we have to switch into the different technology to not switch from the coal into only the gas.
Okay, Pascal, the question for you, I think it's translated. Okay, yeah. I think Pascal and then Valerie.
Waste heat? Is that right?
How is the heat form waste to energy plants classified in France?
Pretty clear. It's 100% decarbonized. 50% is considered as bioenergy because it's the biocarbon that is in the waste. The rest is considered as waste heat, so fatal, unavoidable heat, just for the reason that waste to energy, in fact, is incineration process. So the aim is not to produce energy, it's waste treatment. So in that respect, in France, it's considered 100% as waste heat or bioenergy. There is one specific case, what we call CSR in France, which is plant which is using waste, but the aim of the plant is not waste treatment, is producing energy for industrial sites. In this case, as the aim is to produce energy, what is non-biogenic in the waste is considered as fossil, and then it's about 50% decarbonized and 50% with the carbon content, the average carbon content of waste.
Pascal, what are the biggest barriers for development of the district heating in French cities?
Strange because it changed dramatically. Through the energy crisis, we're in a situation where there are so many demands to develop. Each time a contract is renewed with an operator, the request is to double or triple the size of the district heating. And there are a lot of projects to create district heatings in cities that are not equipped yet. So it's a booming industry. However, again, if we want those district heatings to be competitive, as it is first equipment, like any infrastructure, it requires at least a certain level of financial support, state aids. And the demand is huge and the budget is somewhat limited, so it's one of the issues. But basically, we are rather on a very strong growing trend.
Okay. Valerie, I don't know if you can see the questions. It is in English. Energy efficiency is key driver for decarbonization of energy. Do we use it in sufficient manner, or what is still the potential? Please replace the microphone.
Thank you. It's a very wide question. Do you mean, I guess the question is at EU level. So there is probably a need for a better recognition of energy efficiency as a key factor of energy security, which is now a new focus of the EU policies. So not only for energy transition needs, but also for energy security, as was said by a few of the speakers here today. The key driver for decarbonization is also sometimes hidden by the new mantra of competitiveness. But energy efficiency is part of brings industrial competitiveness. So some EU policymakers are aware of that. Some of them do not seem so aware, but this is crucial that the potential of energy efficiency be fully related, correlated with energy security and economic competitiveness, also based on the fact that public funding has to prime the pump. To get further benefits, investments are needed at cost.
Still one more question, Tomasz, to you, which is dealing with switching from coal to gas could be considered strained cost since natural gas is not carbon neutral?
Yeah, this is what I said you before, that for us, when a huge program for the switching only for the natural gas was implemented in Poland, we right now, especially after the war in Ukraine and the problem with the supply chain, completely we know that this is the again trap. But the critical for the Poland is that currently we should switch from the coal because the huge cost of the CO2. And for the currently, as of today, for the big systems, as I said, with the capacity more than 1,000 of the thermal capacity, technology not exist to switch from for something. We are thinking about the diversification. We are thinking about the different technology, and investment in the natural gas was in the Poland stopped right now.
Okay, it's a very nice question to Francisco. If you could take only the one challenge or measures which should be based on the applying of artificial intelligence for the energy efficiency, what it could be? Only one.
Only one.
The most simple questions are the difficult.
I think I would do something like talk to my plant. So having artificial intelligence that you can talk to in your natural language to help you reduce the energy consumption in your building. When you are a technician or an operator, and we see that very often because we operate plants, in theory we know what to do. But we see that in practice it's very complicated to have your technicians really applying it, doing the proper maintenance, or even explaining to the customer what they can do to reduce the energy consumption. And having this, so obviously it's an AI, so it's based on the data, it's based on the actual energy consumption in the building, but actually supporting the technician who will work there to be even more efficient. I think that's the first thing, because that's really what will help leverage all the rest. You know, it's a bit like what people say, artificial intelligence will not steal your job, but someone using artificial intelligence will. And so I think we need to use artificial intelligence to augment, to improve what our people on site can do.
Because the academic space in our university, we are trying to teach our students, first of all, we should have a database. Database of energy consumption, database of climate conditions, database of emissions, and so on. So if we have database, then we can find solutions, and of course, as you mentioned, using the artificial intelligence. Okay, we have still time or no? Máme ešte čas?
Máme ešte pre mňa na jednu otázku.
Pardon? Aha, dobre, tak potom to vybavíme. It's one question, the last one. What do you think, maybe for all of you, if we will have the tax from the emissions, how it will influence the domestic household sector? Nobody knows.
It raises two questions. The first one is acceptability. So what is important is that, as I said, carbon as a cost should have a price, but this price should be progressive enough to allow people to put in place answers, and answers start with energy efficiency and then decarbonization. And part of the acceptability is what you do with this money. Do you use it to fund your budget globally, which is going to be a bit of a problem? Or do you use it to help people reduce their energy consumption, decarbonize, hence reduce the cost, and you enter into a virtuous circle, which is exactly what ETS2 is about.
No, I agree. I think it's really where you address what you do with that money, and it's the wheel that I was showing, and it's a virtuous circle. So at some stage you need to put some money in to have that wheel going around.
Okay. Valerie or Tomasz?
Yeah, just from my side, clients are more and more, conscious about what's going on. It started many years ago when the neighbors saw the PV on the roof of the neighbors, and thinking, okay, if my neighbors invest, why not me? And right now, and they are starting to ask before, many years ago, about the green electricity. Mm-hmm. Right now, and this is questioning also to Veolia, to our company, the clients, right now, this is the stage when the industry clients, they are asking about the green heat. This is more and more often because they are conscious, because they have their own strategy that they may exist in the Poland. They may produce some goods only if the all electricity, I mean all energy, electricity, heat, and cool is delivering from the green or from the waste. So we have the challenge with that, and this is my answer for that.
Okay. Maybe Valerie, if you would like to add your answer.
Maybe there's quite new challenge in the dimension of ETS2 or taxation compared with ETS1, which was addressing 20 megawatts and more installations. So for more individual dimension actions, there is to be other kinds of collective action, such as at city level or at street level or etc. Because tackling individual or smaller installations level is a different exercise. And for this exercise, transition is key, progressivity and planning.
Stano, čo si ty myslíš na Slovensku? Je to možné, že to ovplyvní? 1 minute, yeah?
Yeah,
okay, you can.
Just to add to what I said, well, this money should be used to help people reduce their energy consumption, meaning sometimes invest. But it is where I put back my hat of president of EFIEES. Investing in buildings is fine as long as it delivers the expected energy reduction and that you stick with it. And what we've seen in many countries, and there are a lot of studies that demonstrate that, is the famous rebound effect. You invest on a building, energy consumption drops if works are done properly, but if you don't maintain it, if you don't operate it, if you don't energy manage it, then it grows again. And you waste anything between 30% to more of the expected savings. Hence, the fact that investing is fine, but don't always think about assets, think about how the assets are managed and how the building is operated.
Takže na Slovensku?
Samozrejme, že ETS 2 bude mať vplyv na rodinné rozpočty. ETS 2 je podľa mňa sociálny problém, preto lebo tí ľudia budú platiť za tie palivá viac. Budú mať uhlíkovú daň v cene. A nikdy tá spotreba, to zníženie tepla v tých bytoch nedosiahne na tú výšku, čo platia viac. Druhá vec je, tieto peniaze by mali byť využívané ako sociálne peniaze na dotovanie, adresné dotovanie cien pre tú časť obyvateľstva, ktorá na to nemá. Ale kde skončia tieto peniaze, dnes nevieme, preto tak ako nevieme, kde skončia peniaze z ETS 1. Z ETS 1 sú to ťažké miliardy eur, ktoré už dnes vyberáme a ktoré naše zdroje na 20 MW už dnes platia a náš spotrebiteľ je tým zaťažovaný. Takže ja poviem svoj súkromný názor. Vyberiem vám z vrecka 10 eur, potom vám 3 eurá dám na nejakú dotáciu a budem sa tváriť, že je všetko v poriadku. Myslím, že týmito opatreniami predbiehame technologickú znalosť a technologický pokrok v tom slova zmysle, že ešte nemáme náhradné riešenia, nemáme riešenia na zníženie fosílnych palív a až také, aby v podstate to tí ľudia uniesli. Kedysi boli párne rušne, žiadne nariadenie párne rušne nezrušilo. Ale technologický pokrok v dízlových strojoch nahradil párne rušne, technologický pokrok v elektrike nahradil dízlové rušne. Dnes máme elektrifikáciu a čistú železničnú dopravu. Niečo podobné, nenásilné, sa musí udiať aj v energetike. Ale ak to budeme robiť, budeme tlačiť na pilu, nedosiahneme to, čo sme chceli dosiahnuť, aj keď ten cieľ môže byť ušľachtilý. Ja by som v tomto smere opatrne posunoval a sú rôzne názory na zavedenie ETS 2 od 1.1.27. To, čo sa národné vlády boja, poviem otvorene, je to, že sa zdvihnú ceny energií a ono to má vždy dopad na výsledky volieb. A preto treba opatrne dávkovať už dnes. My sme nakupovali plyn v roku 2021 po 20 €, dnes ho nakupujeme po 45 a k tomu si treba pridať ešte zhruba tretinu emisnú povolenku. Keď toto zasiahne aj domácnosti, ktoré dnes neplatia žiadnu uhlíkovú daň, žiadnu emisnú povolenku, bude to mať dopad na tých obyvateľov a tí budú mať na to zase svoj názor. Ja som zástancom, aby sme legislatívu nepredbiehali technologický a rozumový pokrok spoločnosti.
Ďakujem pekne. Chcel som povedať, že si to dobre zorganizoval, ale asi je to pravda. Máme posledné 3 otázky. Pascal, it's the question on you. You have had in your presentation that the share of the renewable energy sources in district heating systems in France is 65%. What is the main driving engine for this rising up?
Well, if you had asked the questions 1 year ago, I would have answered differently, because there has been a lot of discussions about how much is available in terms of biomass, because we are very much conscious that we use a lot of biomass. There is a huge potential in France, because we have a lot of forest. However, we must ensure that the carbon sink is protected. So for the time being, we are slowing down on the growth in terms of biomass usage. Still, there is some potential. Then there is this initiative I mentioned about trying to find more geothermal resources. We have identified 3 regions with deep geothermal energy resources. There is now a mission which has been launched by the French government to try to map other regions to see if there is potential for deep geothermal. Then there is surface geothermal energy and a huge untapped potential, which is waste heat, industrial waste heat, as I explained. The whole of the cells is currently 30 terawatt-hours in district heating. We aim for 90. As I explained, there is 100 terawatt-hours of waste, industrial waste heat unused. Obviously, we can't recover all, but there is quite a large chunk which could be leveraged. We have identified about 3 readily available if we find the right way to make these projects get off the ground. And obviously, heat pumps are going to have a growing role in our energy mix.
Thank you. Tomasz, you presented 5 case studies. The question, which one from presented case studies do you consider as the most successful or effective?
No, I presented only projects with the successes, so there is no one. We are proud for this first one about the green heat. This is in Poland the first one when we're using the storage system, ground storage system, and also the low temperature grid. So we are proud of this one. But for all of them, and we are testing right now of them. As I said, this is data about on these projects are available on the network, so you can see inside how it look like. And for the whole project, when we set up the targets, we fulfill and we deliver. It was like our promises, and we did it.
Ďakujem. Last question before I will...
Otázku.
Otázku?
Na Tomáša.
No dobre.
Môžem?
No.
Tomáš, vravel si, že v Poľsku, čo sa týka tepla alebo ďalkovo vykurovania, chcete preskočiť plyn a prejsť v podstate na iné zdroje, teplo z odpadu, biomasa a geoterm. Dnes máte uholné elektrárne, ktoré vyrábajú elektrinu a teplo. Teplo dáš na bok a teplo pri výrobe elektriny alebo výrobu elektriny čím nahradíš? Alebo to teplo, ktoré získavaš pri výrobe elektriny, to pôjde kde? Lebo pri každej výrobe elektriny a z uhlia, turbíny vzniká teplo. Kde ho dáš? Dobre. Kým si rozmyslíš, pán Pascal Guillaume odchádza, letí a zajtra má niečo v Európskej komisii, takže ho ospravedlňujem, veľmi pekne mu ďakujem za účasť.
Thank you for the question. Your last sentence was very important because I couldn't understand with the translation that in all process when you are generating of the electricity you have the heat. And what is the question? Yeah, I couldn't. Sorry for the interpreters, but I couldn't understand. Can you?
If I understood that what you are doing with the heat, which are the heat losses during the combustion process by production of electricity?
You mean in CHP?
Yeah.
Yeah, we have also as I said, energy efficiency is the first. So
Yeah.
we are also using the projects to using the heat even from the processes. So right now, for example, in the CHP in Łódź, we are in the final stage of the using of the heat exchanger of the system, using of the heat from the system of the
yes,
using
the waste heat
exactly
from the
like that,
system.
and using as the waste heat for the internal production. So we are also active on that.
OK, posledná otázka, last question. Poprosím pana Filipa Urbana, keby nám povedal, čo je to CCU technológie. Ja neviem. Potom ako? OK, the question for our panelists, because I didn't know what does it mean CCU. When you are planning to apply CCU technologies in the district heating systems?
If I may, we have this technology in our scope. This is beyond 2030. Right now we are carefully looking for the project in the Finland. In Helsinki, there is a project related to the CCU and CCS in the waste to energy. And also, as I said, in this revision consultation project of the ETS, the Commission is thinking about the implementation of the negative emissions, negative ETS, to support of such kind of the investment. Of course, currently, from our perspective, we have completely different, challenges and advantages. As I said before, switching from the coal, CCS for today for us is too expensive, but we are looking for that, and I believe that beyond 2030 it can be technology, and it can be additionally market coupling, this time with the gas sector, with the crude oil sector, because as you know, CO2 and CCS, CSU was set up in Norway by the companies which use CO2 for the extent crude oil and gas. Thank you.
Okay, thank you. I think that we can slowly close our panel discussion. I would like again to thanks to all of panelists. Big applause. I don't know if only in Slovakia, but we are saying the last word belongs to the woman. Valerie, if I can ask you to as the Secretary General of Association, maybe to make summary from our discussion.
Thank you very much. It's a very hard task for my fragile shoulders. THC is a highly regulated business at national level, technically, let's say, and also economically. But there is a layer of EU regulation which you are aware of. And in this field, it was quite simple, this regulation. It's regulating efficient district heating and cooling, so with a decarbonization path. So every 4 or 5 years in the future, you have more zero carbon energies in your energy mix and less carbon solutions. And this is something that gives you the right way forward, let's say. And it's true path for decarbonization. And as a complement, buildings that are connected to such efficient district heating and cooling systems are considered zero emission buildings, even if, yes, practically they are not zero emissions buildings, but if that had not been the case, that would have been death signal for you and very bad signal for decarbonization of users. So this is just to show you that successful regulation is never to be taken for granted, because it was discussed for long months before having those two pillars, the efficient district heating and cooling and connection to buildings with, okay. So this is a permanent concern that we have at EU level, to make sure that the regulations push and promote the right solutions. So what we have now facing as the next trends is that district heating and cooling and thermal solutions for heating, I mean efficient ones and decarbonized ones, are viewed as allies for energy security, which they are, but it's not always publicly mentioned. And that they are also viewed as an ally for competitiveness, economic competitiveness. And this is not taken for granted, because sometimes we see that energy efficiency means electrification or the reverse. So electrification is one of the tools. There are electric solutions in district heating systems. Okay, but there are still thermal solutions and heating needs. So this is why the debates at EU level remain very important in the next years, to make sure there is a strong implementation of what has been already adopted. No big changes in regulations, otherwise it's unpredictable for you. You don't know what to do in the next years. You can't make projects because you don't know where to start and where to finish. And there is a need for public support that you know better than me. But public support is the first layer of the action. Just as Mr. Janisch was mentioning, there is a need to compensate extra costs of energy savings to start and make sure that for the citizens it's quite neutral. Otherwise it's just perceived as costs. So this is a few conclusion words from my side to say that the EU level remains a critical and important one.
Takže pomaličky, ale isto sa blížime k záveru. Taká hutná debata a more informácií v krátkom čase na jednom mieste. Ale super, tak nejak to má byť, čo sa týka efektívnosti, lebo aj v tejto činnosti je dobrá efektívnosť, nielen vo výrobe tepla a v jeho distribúcii. Tak ako z každej konferencie odbornej budú jednotlivé témy, alebo to, čo tu zaznelo, v nás ako dozrievať. Budeme si ich porovnávať s tým, čo máme doma, čo sa dá, čo sa nedá. Či aplikácia, príkaz v Poľsku bude sedieť u nás a či sa to dá, alebo nedá. Niektorým sa vrátime, niečo si osvojíme a niečo si neosvojíme. U nás v podstate pri tej hustej plynofikácii a máme 36 000 kilometrov rozvodov plynu. Každá dedina u nás, každá obec je plynofikovaná. My v našich systémoch viac ako 50% tepla robíme z plynu, či už priamo v kotloch alebo v kombinovanej výrobe, v kogenerácii. To značí, že my máme za sebou uhlie. Uhlie v podstate hrá u nás ešte maličké percento, takmer nič v ďalkovom vykurovaní. To značí, že my nejakú tú etapu už máme za sebou a stojíme pred etapou, ako teda maximálne dekarbonizovať. Naša cesta v podstate na Slovensku bude viesť a stále musí viesť k efektivite spotreby tepla na strane spotrebiteľa a na druhej strane k efektivite výroby a distribúcie tepla smerom k nášmu spotrebiteľovi. Po druhé, budeme musieť maximálne etablovať stabilné obnoviteľné zdroje. Pod tým mám teda na mysli hlavne geotermálnu energiu, tam, kde v podstate sa dá. Veľkou otázkou zostáva ešte využitie tepla z 2 jadrových elektrární, Jasovské Bohunice, časť Trnava je vykurovaná z Jasovských Bohunic. Máme tu ešte Mochovce, máme tu nejaké ďalšie možnosti, aby sme toto obrovské množstvo tepla nejak etablovali a nemuseli ho chladiť v tých vežiach. Čo sa týka technológie, musíme pokračovať samozrejme v tých najnovších technológiách, ktoré nám jednak zefektívnia výrobu a jednak v podstate nám zefektívnia distribúciu. Investujeme, koľko sa dá, len si treba uvedomiť, že každá investícia znamená zvýšenie ceny pre nášho spotrebiteľa. A preto aj investovať musíme veľmi opatrne, aby sme tých zákazníkov alebo spotrebiteľov na seba naviazali a nie ich ešte vyššou cenou v podstate odputávali. Netlačme na pilu, aby sme tie systémy v podstate zachovali u nás. Takže plus, keď k tomu pridáme, nazvime to umelú inteligenciu, smart riešenia, akékoľvek riadiace systémy na tých našich systémov ďalkového vykurovania, ktoré povedú k vyššej efektivite, k lepšiemu predvídaniu nasadzovania jednotlivých zdrojov podľa počasia, podľa ceny paliva a tak ďalej. Toto všetko je budúcnosť, ktorú my budeme musieť manažovať tak, aby ten náš spotrebiteľ zostal u nás na ďalkovom vykurovaní, aby sme v mestách zachovali čisté ovzdušie a aby aj ten biznis pre tých výrobcov a distribútorov tepla mal nejaký efekt. Ďakujem panelistom, ďakujem tebe, pán profesor, za klasické profesionálne manažovanie odbornej debaty a ďakujem všetkým účastníkom, že ste merali čas a cestu smerom do Bratislavy, napríklad ako ja, aby sme si vypočuli a navnímali niečo, čo sa deje okolo nás, aby sme možno poprvé vedeli, už sme ďalej, ako sú ostatní, s tým sa radi pochválime, alebo keď nie sme tak ďaleko, tak makajme, aby sme ich dobehli. Príjemný návrat domov prajem.